Hi, we are on day 6 at Algebra 1 for Presentation High School. We do 4 hours of math per day, and we're on day 6. So we are on, we finished 5 days or 20 hours of math in Algebra 1, and we're going to do hour 20 through 24 today. Remember that this, hi Annie, that's my dog. Remember, this is not a substitute or a replacement for what we learn in class. It is reinforcement of the most important things we do in class. And for the past few days, I've also been giving a few review problems that ensure that you're remembering what we've learned from prior days. So if you only care about review problems, you could take this video and fast forward it near the end and just do those few review problems. If you're interested in what we learned in class today on day 6, some of the key points are covered in this video. Let's get on with those key concepts. Okay, so what are we doing? Primarily today, what we're doing is solving systems of equations and learning a new way to solve systems of equations. And in fact, this is probably the most common way. All of the methods that we use today are the most common ways of solving systems of equations for those very skilled in doing so. Let me go over a little of the rationale conceptually how and why what we're doing works. So what I'm going to talk to you about is how we can solve this system. If I know that two numbers added together are 6 and their difference is 12, how can I solve this equation? Okay, well, let's think of these, and this again, this is the conceptual understanding, and then we'll get into how you actually do it, the fluency portion. So we're going to start again with the conceptual, how does this work, and move into the fluency. This is kind of the how, and this is kind of the why. How does it work, fluency, why does it work, conceptual. Okay, so I have this balance. So I know that if I have x plus y on this side and a 6 on this side, that my two things balance, right? Because they're equal. Well, I also know that these two numbers, if I take their difference and put them on a balance, they will balance as well. So if I have something balancing on a seesaw, call this a seesaw, and then I take something else that balances, I can take this thing here and stick it on here, and I can take this 12 and stick it on this side of the balance, and the whole thing should still balance. I should still have an equality, right? So if I take x plus y and x minus y and add those together, and I have a 6 plus a 12, if I add the right side together and I add the left side together, everything should still balance, right? Similarly, if I have, some x's or let's take some balls over here that balance with some bricks over here, and I know that balances, and I have, Joe here, and I have, Susie here, and those, they balance. I should be able to take those balls and give them to Joe, and take these bricks and give them to Susie, and they'll still balance on this balance. Hopefully that kind of makes some intuitive sense about why what we're doing today works. Okay, so now what we're going to do then is say, hey, if I have an equation that balances and another equation that balances, I can just take this piece and add it to that piece, take this piece and add it to this piece, and I should get an equation that still holds together. So let's do that. Let's add these guys together and set them equal to adding these guys together. Well, on the left side, I get x plus y plus x minus y. And on the right side, I get 6 plus 12. Well, if you remember back to combining like terms, we have a minus y and a plus y and a minus y. those things are going to cancel. And on the left side, I'm going to have basically 2x. And on the right side, I'll have 18. And if I divide both by 2, I can get x equals 9. And we're going to go back at this point and do exactly what we used to do in substitution. Take our x value and plug it back in up here to either equation. We'll use the first one. And I'll say, well, x plus y equals 6. And now we know what x is. X is 9. So 9 plus y equals 6. So if I subtract 9 from both sides, I get y equals negative 3. So my point, or my solution, is 9 comma negative 3. Now I can check that using the other equation. Just like we did in substitution, if we found the other variable using the first equation, we're going to check using the second equation. So let's do that. 9 minus negative 3, does that equal 12? And the answer is 9 plus 3 does equal 12. So that's a check. So my answer, again, 9 and a minus 3. And I'm going to commit to that with a nice strong box around it. So let's do this again. Let's do this one more time, or a couple more times. And I want you to practice. So I want you to pause and try yourself. And then we're going to come back and we're going to solve these. All right, I assume you've tried them. Hopefully you got the right answers, but let's just see what happens. So let's add down. Now, rather than write this thing out like 2x plus y plus x minus y, I can just add these down by combining, I'll just combine the like terms just straight down rather than have to do it later, because I know all these are added together. So if I add these, I'm going to get 3x, my y's cancel, and on the right side, I get 9. So I get x equals 9. Now, I'm going to let me use my second equation here. X minus y equals 4. And we'll say 9 minus y equals 4. So subtract 9, negative y equals minus 5. So y equals 5. Is that right? That's not. This is so wrong. I am so sorry. Look at that. I'm going to catch myself. Because if I would have gone back up here, so if I had this 9 and 5, and I go back up and check here in that first equation, I'd get, well, it's 2 times 9 plus 5. Does that equal 5? And the answer is no. 18 plus 5 does not equal 5. I did something wrong. So I'm going to go back and check my math. And what I see here is that this step here is wrong. That's wrong. X should be 3. So I'm going to go all the way back. And I'm not going to be so humble or so proud that I don't leave my mistake right here for everyone to see. So I'm going to fix it. See, checking your answer is very important. Now we divide by 3, and we get x equals 3. Now I'm going to go back in here, and we'll use the first equation, 2x plus y equals 5, to find our other value. 6 plus y equals 5. So subtracting 6, y equals negative 1. So now I think my point is 3 comma negative 1. Having used my first equation to find my second variable, I'm now going to use my second equation to check my answer. So x minus y equals 4. Is that true? Does 3 minus negative 1 equal 4? And the answer is yes. 3 plus 1 equals 4. Check. So my answer that I'm going to commit to is 3 comma negative 1. Glad I checked my answer. Okay, let's do the same thing over here. Hopefully you got this answer right. 6x, adding down, If I add these down, they cancel. 3x and a negative 3y. 6x equals 16. All right, this is ugly because this is going to end up being a fraction. I hate fractions, but I get what I get. So we're going to divide by 6, and we're going to get x equals 8/3. Divide by 2, divide by 2. So now I'm going to go back and plug into here, and I'm going to get 4 times 8/3 plus 3y equals 11. 32/3 plus 3y equals 11. Now what I'm going to do is I'm going to multiply everything through by 3 to get rid of my fractions. I really always hate fractions. Multiply everything through by 3. So I get 32 plus 9y equals 33. So I get 9y equals 1, or y equals 1/9. Oh my gosh, this is ugly. So I use my first equation to find my y. So now I'm going to check using my second equation. So 2 times x minus 3y equals 5. So 2 times 8/3 minus 3 times 1/9, oh my gosh, equals 5. So does 16/3 minus 3 times 3 over 1, that's 1/3, minus 1/3, does that equal 5? Well, does 15/3 equal 5? And the answer is yes. So gosh, gnarly fraction problem, but we got it right. All right. That's solving by addition. Now, there's solving by subtraction. So notice what happens. If I try and add these guys down, what happens? Well, I'd get 3x plus 2y equals 17. And I haven't gotten rid of one of my variables. Let's go back for a second. And the whole idea here, when we did our adding down, we added these down, we got rid of our y's. When we added down over here, we got rid of our y's. You could have gotten rid of x's, but you made a simpler equation in both cases where you didn't have one of your variables, and then you could solve. So the idea of adding down is also called elimination. So the idea is to get rid of one of your variables so that you can solve. Here, when I add down, I don't get rid of a variable, so I still cannot solve. So let's just get rid of this for a second. Let's do some thinking. What could we do here to make it so that we could solve? Well, just like I can do addition, I can do a subtraction. So I can take two things. If I have an equality, I can also subtract two things that are equal, and I'll still have a true equality. Now, let's do it that way first, and I'm going to show you what I think is an easier way. So if we subtract this, we'd say, well, we have 2x plus y, minus x plus y equals 10 minus 7. So I'm subtracting this from here and this from here, knowing that I'm subtracting equal things from both sides. And then I get 2x plus y minus x minus y, right? I got to do my distribution. That negative minus a positive y, negative y equals 3. And then I can cancel my y's. And then I get x equals 3. Similarly, so that's x equals 3. But let me show you, you could just subtract in part. So I could just say, well, 2x minus x is x. Y minus y is, that eliminates. And then I get 10 minus 7 is 3. So I could have done it that way. Okay. So again, when I do my subtraction, I subtract down and I get x, my y's cancel, and then I get 3. Now when I go back and I solve, I'm going to solve using this guy. So I'll say 3, and then this is the same as we've done with elimination, or sorry, solving by addition. It's the same as solving by substitution. We just go back to one of the equations and find the other variable. And then we check using the equation that we didn't use the first time. So we use this to find the second variable. So we're going to use the other one to check. So 2x plus y equals 10. So does 2 times 3 plus 4, does that equal 10? 6 plus 4 equals 10. Check. Let's just go ahead and put down a happy cat here, just because we're happy because we got the right answer. And again, the answer is 3, 4 box. Now, the other route that I like to use is turning addition problems into subtraction. So this is the route that I would normally use when I'm solving these subtraction problems. So watch what I do. 2x plus y equals 10. And over here, I have x plus y equals 7. Well, I know I can do subtraction, but instead, I'm just going to turn this into an addition problem by multiplying the second one times -1. So I'll take my top equation, 2x plus y equals 10. And if I subtract everything here by -1, I get -x minus y equals -7. I've multiplied all the terms by -1, which is totally legal to do, right? I just basically use my multiplication property of equality and then rewrote the equation. Now I can just add down. How cool is this? Because I add these guys down and I get x. I add these guys down and they cancel. And then I add these guys down and I get 3. And then I'm right at the same place as I was here, and I would solve the exact same way. So I like to go turn addition or subtraction problems into addition problems, and that's what you're going to see me do in the future. But no, if you can just do the normal subtraction here, you can continue to do that. I'm going to do it this way. All right. Now let's look at a different problem. Here, again, the goal is to come up with a way to eliminate one of your variables. Well, here, I can't add these together and make them go away. I can't subtract them, change their signs, and add them together and make them go away. So how can I make two equations that can be added? And let me give you the hint. I'm going to multiply first. You can multiply some number by the top or the bottom in each, so that the elimination will easily happen. And what could I do to this top one? Well, let's think about if I doubled this top one. So we're going to do this one together. And I multiplied by 2. I still have an equality on top, because I would have 2x plus 4y equals 2. And then my bottom one, I can just leave the same, and I get 5x minus 4y equals -23. Now I can just add down. 7x equals, these cancel, equals -21. Dividing by 7, I get x equals -3. And now I can go about substituting back into these equations up here. So let's do that. So x plus 2y equals 1. -3 plus 2y equals 1. Add 3. 2y equals 4, y equals 2. So my answer is -3, 2. Now I'm going to continue to check my answers, because that's a good practice. So 5x, 5 times -3 minus 4 times 2, does that equal -23? Does negative 15 minus 8 equal negative 23? And the answer is yes. So we're going to lay down our happy cat because we've verified our answer. We don't need to wait for Mr. Lipscomb to check our work tomorrow or anyone to check our work because we have checked it ourselves. And that's why the happy cat is smiling. Now let me ask you a question about this other problem. We need to multiply the top and bottom here by a number to eliminate one of our variables. So in this case, we could multiply the top or bottom by a certain number to get one of our variables into an elimination position. But here I can't really do that because there's not an easy integer I can multiply the top and bottom by to make them eliminate. If I multiply the bottom by 2, my y is too big. If I multiply the top by, I can't make it my y smaller by multiplying by an integer. So what we have to do is multiply the top and bottom by a certain number. And usually the easy thing to do is to multiply the bottom by this number and the top by this number. So let's watch what happens. So I'm going to take this 3 right here, multiply the bottom by this number, and multiply the top by this number. And you'll see why that works. Because 3 times 2 is the same as 2 times 3. That's why we just cross those numbers, and that will always yield something that a situation where we can do elimination. So if I multiply the top by 2, we multiply everything by 2, 14x plus 6y equals 56. And again, I've just used the multiplication property of equality to take an equation that's true and just double the size of both sides. And I know that that will leave it in a state where everything is still true. Now let's do that with the bottom. 3 times 9 is 27x minus 6y equals 108. So let's just add those together and we get 41x equals 164. And if we divide both of them by 41, we get x equals 4. Now we got to make sure that's true, so let's plug it back into this first equation. 7 times 4 plus 3y equals 28. Is that true? Does 28, oh no, we got to find what our y is. Oh, this is going to work out neat. Oh, watch what happens here. 3y equals 0, so y equals 0. So let's check that out in the second equation and see if we got a pair of numbers that work. 9 times 4 minus 2 times 0 equals 36. Does 36 minus 0 equal 36? The answer is yes. Bam. Happy cat. All right, so that's solving system by multiplication. Sometimes you have to multiply one equation by a number, but often you have to multiply both equations by a number. Finding that key number is usually just using the coefficient of the smaller number to multiply, and then you can create an elimination situation. All right, sometimes let's go one step trickier. One step trickier, and that's we have to rearrange first. Notice in this case, oh, this has got a couple problems with it, but in this case, we don't have, variables that even line up. They don't even line up. So in this case, what I want to do is I want to create, want to line up the variables. So we want to get the x's and the y's on the left. So in this first equation, we need to subtract our y's to get them on the left side. You'll see. So if we subtract 2y from both sides, we get x minus 2y equals negative 6. And on the bottom, we have a half x plus a half y equals 3. So this is now in our familiar form. There's going to be a lot of problems that you're going to do with this rearranging first. Okay. Wow. I hate dealing with fractions. So let's just, before we do anything else, let's just deal with these fractions over here. So let's multiply this bottom equation by something that will get rid of all our fractions. And what number is that? what can I multiply every term by to get rid of fractions? Did I hear a times 2? I did. So we're going to multiply everything times 2. 2 times a half x is x. 2 times half y is just a y. 2 times 3 is 6. And on the top, we have still x minus 2y equals negative 6. Okay, so this is cool. We can now either try and eliminate our x's, or we can do a multiplication to get rid of our y's. I just think we should let's just eliminate our x's by multiplying, turning this into an addition problem. This is a subtraction problem. I'm going to turn it into an addition problem by multiplying everything by negative 1. And then I get negative x minus y equals negative 6. And now I can add down. These guys cancel. I get negative 3y equals negative 12. Divide everything by negative 3. And I get y equals 4. So now I'm going to take it all the way back to my original, one of my 2 original equations to find my x. So my x is equal to 2 times 4 minus 6. So x equals 8 minus 6 equals 2. So x is 2. So I have 2 comma 4. And I want to check my answer with my other equation. Have to go back to the original to be absolutely sure. So is half of 2 plus half of 4. Does that equal 3? Is half of 2, which is 1, plus half of 4, which is 2. Does that equal 3? Yes. Oh my goodness. Happy cat. Happy cat. 2 happy cats. 3 happy cats. 2 comma 4. All right. Now we have one more problem. One more elimination problem. And I've done a lot of the work here for you. This is a word problem. I've done a lot of the work, and it becomes an elimination problem. So notice, you're at the store buying bats and balls. We've done this in this kind of equation in class, but I'm just kind of helping you through it, kind of giving you some guidance before I'm going to let you solve it. And then I'm going to let you solve it. Okay, so you're at the store buying bats and balls. Bats cost $20. So one bat equals $20. One ball is $8. But you notice that you spend $104 on 10 items. So you buy a combination of bats and balls, 10 items total, and you want to know how many balls and bats did you buy? Well, we're going to call x the number of bats and y the number of balls. So x plus y we know is the number of total items. So what is the cost of x bats, the cost of y balls? And then you're going to create your equation 2, which is your cost equation. Okay. So if I buy x, so I want you to pause and try. Pause and try if you're confident. If confident, pause and try the whole thing. Fill this in, fill this in, fill out these equations, and then solve and tell me how many bats and balls you bought. If you're not, obviously you just wait for me to keep going, and I will. Okay, so now we're back. I assume those of you who wanted to tried it, got the right answer or something close, or maybe you're now a little bit more instructed or have a better idea about where you might want to be going with this problem. And I always encourage you to try these, because you're going to learn more if you try and fail than if you just watch me do it. So the cost of x bats. If a bat costs $20, remember my T-chart. The number of bats, if it's 0, I get 0. You know, and then if it's 1, it's 20. If it's 2, it's 40. If it's x, it's 20x, right? It's times 20, times 20, times 20. So x times 20 is 20x, okay? So the cost of x bats, if I have, is basically 20x. And similarly, the cost of y balls is 8y. So now I am totally set up to solve this equation. My total items, the number of bats plus the number of balls is 10. the total cost. The cost of my bats plus the cost of my balls is 104. Now we can solve by elimination. Well, what do I need to do? Let's multiply the top by 8. And the bottom will just leave the same. So 8x plus 8y equals 80. In the bottom, I have 20x plus 8y equals 104. Why did I multiply by 8? Because I want to create this elimination situation. Now, I can't just add down. I need to multiply my bottom by -1 or my top by -1. So let's go ahead and do that. What I could have done is said, hey, wait a minute. I want to create an elimination situation. So I want to multiply my top by -8, not 8. So I'm just going to erase this. And if I would have multiplied by -8, I would have got -8x minus 8y equals -80. And now I have my elimination set up without having to do another step. So those cancel. And when I add down, I get 12x equals 24. Or x equals 2. So if x is 2, that's 2 bats. And then my balls has got to be 8, right? Because if x plus y is 10, then my y is 8. And so we have 8 balls. Let's verify. So we know that we use this equation to find our second variable. Now let's check it using our cost equation. So 20 times 2 plus 8 times 8, does that equal 104? Does 40 plus 64 equal 104? And the answer is yes. Wow, cool. Happy cat, happy days. That's the end of our system of equation. Now I'm going to do 3 review questions that may appear, hint, hint, very close, on your quiz tomorrow. So 17 is, we'll do these in blue. 17 is 25% of what number? Well, let's use our strategy. Of is times, is equal, numbers are numbers. The question what is an x? 25% we need to convert into a decimal. Okay? This is one way to do it. So 17 equals 0.25x. And because you have a calculator, you can actually just do this very nicely. Divide both by 0.25, and then you're going to get x equals 68. For those of you who are super clever and don't like calculators, you could have said, well, 0.25 is the same as a quarter. So 17 equals 1/4 x, and then multiply both sides by 4. And you get 68 equals x. So either way, that's great. What is the equation of a line passing through -7, 4 with slope of 1/3? This is just point slope. We have a point and we have a slope. We can just write this equation in point slope form. I hope you saw that. So our x1 is -7 and our y1 is 4. So y minus 4 equals 1/3. X minus -7 is x plus 7. Boom, done. And if you wanted to, you could have converted that into into standard form or slope-intercept form, but it's not required because I didn't say what type of equation. You could write that equation in any form you like. All right. Finally, number 3. What is the slope of a line parallel to a line defined by y minus 4 equals 2/3 x plus 10? Well, this is in point slope form. So this is a line through -10, 4 with -10, opposite of this and opposite of this. -10, 4 with slope m equals 2/3. So all lines parallel to this line must have a slope of 2/3. So there's our answer. The slope of all lines parallel to this line is 2/3. And with that, we are done with today's lesson. All done. Good work. Hopefully these videos are useful. Please comment if you need any help with the video. If you want me to do more examples, if you need help with explanations, if there's any other critical feedback for me so that I can help you better. Otherwise, I will see you in class. And happy cat, happy math.